We just learned about the type of operator which allows us to distinguish between numbers, strings, booleans, and objects, but it does not tell us what type of object it is. It cannot differentiate between objects. And that's where instance of comes in. Instance of is a way to figure out how did this object get constructed? What kind of object is it? It's a true paternity test. So if you want to tell if an object was built using a particular constructor, you will use instance of. We've spoken about object constructors and we've seen an example of the rectangle constructor. If you want to know what constructor was used to build this object, you'd use instance of. The instance of operator returns true or false. It doesn't give you the actual instance, it'll tell you true or false. If an object was built using a particular constructor, if the answer is yes, instance of will return true. If an object was not built using a particular constructor against which you're comparing it, instance of will return false. Let's see how instance of works. Let's say that we have an object constructor and we'll work with an object constructor that we are very familiar with, the rectangle object constructor. Using this rectangle object constructor, let's say we create a number of objects, and let's say we have other objects which we don't really know how they were constructed. We don't know whether they were constructed using the rectangle constructor or some other constructor. So we have a whole bunch of objects and we are not sure what type of objects they are, whether they were built using the rectangle constructor or some other constructor or in some other way. Let's say that these objects are represented by the object names or the variables rectangle2 and rectangle. Don't be misled by the names. The name rectangle does not mean the object is actually a rectangle. A name is just something you call that object. We want to conduct a paternity test to know whether these two objects, rectangle2 and rectangle, have been constructed using the rectangle object constructor or not. This paternity test will be carried out using instance of. Remember that we had said that to tell if an object was built using a particular constructor, we use instance of. Take a look at how we use instance of. We say rectangle to instance of rectangle or rectangle instance of rectangle. This returns either true or false. So was rectangle 2 instantiated with constructor rectangle? Instance of says true. Was rectangle instantiated with the constructor rectangle? Instance of says false. Note that instance of gives a true or false answer. This is different from how type of works. Type of will give you an answer saying string, number, undefined, etc. Instance of will respond true or false to your question. So you have to ask the right questions. You have to say, is this object an instance of rectangle? Or if you have an object constructor called triangle, you can say, is this object an instance of triangle? And instance of will say true or false. The use of the operator instance of is very easy indeed, but there are some subtleties that you need to watch out for. No matter how much you change an object after it has been constructed, whether you add or delete properties, its instance of behavior will remain unchanged. So let's say you have this rectangle, you constructed it using the object constructor for rectangle, and then you added a whole bunch of properties. You've changed an object. No matter how much you change an object. Let's say you add properties, you add function properties to an object, you delete properties, you remove existing properties which are defined in the rectangle constructor. Even then, the instance of for that object will say true when you say instance of rectangle. It's important to remember when you use instance of, don't expect instance of to tell you everything about an object. It will merely tell you what constructor it came from. It will merely speak of its origins. But if you've changed the object after that, that is unknown to instance of.